name's Pete. I'm VP at Eigenphi. I got into blockchain from the music industry. Originally was a DJ, producer, record label owner, music festival organizer. A friend of mine got in touch with me and said, "What do you know about blockchain?" I said, "Not much." And he said, "Do you want to co-found a music streaming app using blockchain technology?" That was back in 2017. From then on, I disappeared down the rabbit hole of crypto for a while. I now work for Eigenphi. Our CEO and founder is the ex-CTO of Hobby, and he was originally one of the strategic advisors for my blockchain music streaming app. So I feel very lucky to have had this journey and to be working with Eigenphi and to kind of be where I am in the industry today. Any transaction that lands on chain, we analyze it and we take it apart in order to be able to understand it, in order to provide visibility and observability to the industry, to provide them with data that they can really understand what's happening on chain and build better solutions or find problems where they exist and gather insights from on-chain data. Things can get very complex on-chain very quickly, and so we identify, label, categorize, and kind of take the on-chain data and repackage it to make it more easier to understand. I think it's a simple way to explain it. Our data can actually be valuable for a whole host of people. We currently specialize in an area of transaction analysis based around MEV, so that's quite a hot topic at the moment. So we categorize and label things like sandwich attacks, arbitrage, flash loan attacks. There's a huge amount of value contained within a blockchain. We think of it as a dynamic transaction network. The use cases for the data that you can get from that can be applied to understanding how the ripple effect of a risk event. We recently did a report on the Viper exploit. You could also understand user behavior. There's lots of different value points, but the information that we have would be useful for people focused on MEV is the first obvious use case. So wallets, OFAs, searchers, block builders, they find our information and data very, very valuable. Our edge revolves around the way that we do the analysis. So we do dynamic analysis rather than static analysis. And so we actually think that the fundamental element of a blockchain is a transaction. What that means is that we understand the function of addresses from the transaction rather than trying to understand the transaction from like a static understanding or labeling of the address. And that gives us a very big picture of what we call a dynamic transaction network and how that's the relationships between these transactions hold a huge amount of information. A good example of that is we get to understand like the ripple effect that an event might have on the entire network. What makes us different is the algorithms that we use and the technology that we, employ. So one of the big things is that a lot of people still rely on old technology. So SQL is from the 1960s, but it's heavily still relied on. And once you get to a big data size, that can start to cause problems in accuracy of data. So one of the main differences is that we purposely built our algorithms to be able to serve the demands of the amount of size and the complexity of transaction data that is held on chain. And so there's three different parts to that. One is the size of the data, the growth of the data, and the dynamic relationship of the data. So we have three bespoke proprietary algorithms that simultaneously tackle those problems.